I'm going over the Chapter 4 practice test so you can understand how to do these problems. For number 1, you're just taking the cube root of negative 125, which is negative 5. It's pretty straightforward. For number 2, you're taking the cube root of negative 64 and then squaring that. So the cube root of negative 64 is negative 4, and you're going to square that, so you're going to get positive 16. For number 3, you're going to reduce 12 into 96 first. That will give you the cube root of 8, which is 2. If you rather go into primes and reduce that, that'll work as well. For number 4, you're going to add the two exponents. So 5/3 is 10/6 plus 1/6 to the negative 6. So when you add that, you get 10 to the, you get 3 to the 11/6 times negative 6, which is 3 to the negative 11, which is equal to 1 over 3 to the 11th, which is 1 over whatever 3 to the 11th is, which is 3. Let me put that on my calculator. 11 is 177,147. Make sure your fraction bar is long enough to cover all those numbers. For number 5, we're going to put everything into primes, or at least into multiples of 3. So 54 is 27 times 2. Then the exponents, I'm going to make those divisible by 3. So x to the 6th, y to the 3rd times y squared, z to the 9th times z squared. Then you can circle groups of 3, which are perfect cube roots. So the 3 will come out of the radical. We're going to have an x squared come out of the radical. Also, we're going to have a y and a z to the 3rd. And then in the radical, you're going to have a 2y squared, z squared. And that is a cube root, so don't forget the 3 there as well. For number 6, I'm going to distribute this negative 1/3 to everything. That's going to give me y to the negative 2/3. It's going to give me 27 to the negative 1/3. And then negative 1/3 times negative 6 is x squared. When I rewrite this, the x squared stays where it is because there's a positive exponent. The y moves to the denominator and becomes positive 2/3. And then 27 to the 1/3 moves up and becomes positive 1/3. 27 to the 1/3 in the numerator is 3 because that means the cube root of 27. And the denominator just stays exactly how it is, x squared, y to the 2/3. Make sure that looks like a exponent. For number 7, whenever you're adding or subtracting radicals, you must do them completely separately. So you have to keep them separate from each other. So that becomes 3 times 3 times 7. 112, if you divide that, you may divide that by 4, is 4 times 28. So that's going to be 2 times 2 times 2 times 2 times 7. Again, these are square roots. When you take out the number from in the radical to outside, you multiply by the coefficient that's already there. So you're going to get 15 square roots of 7 plus 4 times 2, so 8 square roots of 7. That gives you 23 square roots of 7. For number 8, you're doing f of g of 2, so you got to plug in 2 into the g of x equation. So that's going to give you 2 plus 1, which is 3. And then you have to plug in 3 into the f of x equation, so that's going to give you 9 plus 6, which is 15. For number 9, you're going to plug in negative 3 into the f of x equation. That's going to give you 9 minus 6, which is 3. And then you're going to do g of 3, which is going to be 3 plus 1, which is 4. F of g of x is going to be f of x plus 1. So you're going to put in x plus 1 for all of the x's in the f of x equation. So you're going to do an x plus 1 squared for that x. And you're going to do 2 times x plus 1 for this x up here. So x plus 1 times x plus 1 is x squared plus 2x plus 1. And if you distribute this 2, you're going to get 2x plus 2. So if you add x squared plus 2x plus 1 plus 2x plus 2, you will get x squared plus 4x plus 3. For number 11, we're going to do this part first. So g of negative 3 is negative 3 plus 1, which is negative 2. Then we're going to do f of negative 2, which is going to be 4 minus 4, which is 0. And then we have to do g of 0, which is 0 plus 1, which is 1. For number 12, f of x plus g of x is just going to be 5x plus 3. Whoa, hold on, let me start this over. 5x. I'm not sure why it's erasing everything that I'm doing, so let me start over again. Excuse me. Five x plus 3 plus g of x, which is negative 2x plus 4, which is 3x plus 7. G of x minus f of x is going to be negative 2x plus 4 minus f of x, so minus 5x plus 3. You have to distribute the minus sign, so that gives you negative 7x plus 1. And for number 14, f of x times g of x is going to be 5x plus 3 times negative 2x plus 4. You can use the box method if you want. I'm just going to distribute negative 10x negative 10x squared plus 20x plus the negative 6x and plus 12. So negative 10x squared, this part right here gives you plus 14x plus 12. You can't reduce that because you don't have an equal sign or factor it because it's not really asking you to factor. So you just write that out. Negative 10x squared plus 14x plus 12. F of g of x is going to be f of negative 2x plus 4, which means that in the f of x equation, in place of the x, we're going to replace that with negative 2x plus 4. So it's going to be 5 times negative 2x plus 4 plus 3, which is negative 10x plus 20 plus 3, which is negative 10x plus 23.